In this video, I will show an example of a problem called related rates. And to get started, let's read the question. So a car traveling north at 60 miles per hour and a truck traveling east at 45 miles per hour. As we're reading the question, let's try to understand what's going on. A truck is traveling north. Sorry, a car is traveling north, a car is traveling east, and as the time goes by, the distance between them is increasing. So the question is, at what rate is the distance between them changing 2 hours later? So in order for us to answer this question, we have to first understand the rate of change of what are we trying to find. So let's introduce some variables. Let's denote x, the distance from a car to the origin. Let's denote y, the distance from the truck to the origin, and let's denote z, the distance between the two vehicles. What we know, or what's given, is a car is traveling north at 60 miles per hour. That means the rate of change of x with respect to time is 60 miles per hour. Also, given that the rate of change of y with respect to time is 45. And the question is to find the rate of change of the distance between them. So the question is asking us to find the rate of change of z with respect to time 2 hours later. So first, we have to identify the quantities, the rate of change of which are given and the rate of change of which we have to find. We're looking for the rate of change of z, but the rate of change of x and y are given. That means to find the relation between their rates of change, we have to first establish the relation between the quantities x, y, and z. And by looking at this picture, it is pretty clear that those three quantities are the sides of a right triangle, and therefore the Pythagorean theorem will hold, meaning x squared plus y squared is equal to c squared. Once we have the relation that relates the three quantities, then we can differentiate this with respect to time to obtain the relation for their rates of change. So differentiating it with respect to time, will give us the following relation: 2x times dx dt, because x is a function of time, so x squared is actually a composition of two functions, x and square. Similarly, we take the derivative of y squared and z squared. Now, we know almost everything in this formula, so dx dt is 60, dy dt is 45, dz dt is something that we're looking for. And to use this formula, we still have to figure out what are the values for x, y, and z. Now, if we look back at this question, the question is asking us at what rate the distance between the vehicles changing 2 hours later. So do we know the values x, y, and z 2 hours later? If we know velocity, then we should know the distance after 2 hours. So if car is traveling 60 miles per hour, then after 2 hours, x is 120. If a truck is traveling 45 miles per hour, then after 2 hours, y is 90. And to find z after 2 hours, we can just use the Pythagorean theorem, and z will be equal to square root of 120 squared plus 90 squared. And that we can try and compute. 12 squared is 144, 9 squared is 81. So finding the distance between them 2 hours later is as simple as computing this expression. So 14,400 plus 8,100 is 22.5, and taking square root of 22,500, it should be same as 150. So after 2 hours, the x value is 120, the y value is 90, and the z value is 150. So the only unknown value in this equation is dz dt. So we can solve for dz dt, but first let's divide everything by we can definitely divide everything by 20 to get something simpler. So we get 120 times 6 plus 9 times 45 times 15 dz dt. So dz dt is 120 times 6, which is 720, plus 9 times 45 is 405, and we're dividing all that by 15. So 720 plus 405 is 1125, and dividing 1125 by 15, let's see, 6, actually 7, that's a better choice here. So the answer is 75 miles per hour. So the distance between the two vehicles is increasing at the rate of 75 miles per hour.